Let's go through equal 2,495 numbers of subarrays having even product. For this question, it gives us integer array nums and return numbers of subarrays having even product. Let's look at this example 967 17. So it has six number of subarray which have even products. That is, those six need to include this even number. So what we're thinking about is that we can find those kind of subarray which does not include, which does not have an even number in it. For example, here there is one subarray. Here there are 3, 7, 13, 7, 13, right? Total there are 10. So we use 10 minus 1 minus 3. So that is 6. So what we think about that is we have the length of nums. So the total number of subarray is 2 n multiplied by n plus 1 divided by 2. And then we try to look at this kind of array one by one, right? So if we find the even number, then we can try to see last even number, what's the index of it, right? And then for this range, from last index, even index to current index, so last even index plus 1 to current index minus 1 are all odd number. So those subarray does not have even number. We can count this part. Then we move point to here, right? And then calculate the next part. So we use the total to minus total subarrays minus total even those kind of subarray with only even numbers in it. Then that's the result. So let's begin to write code for this. And I have int I on start length. And we will say this is long, right? So you will have result. Long result equals 1 multiplied by a multiplied n plus 1 divided by 2. So we'll say we have index last even number, and at the beginning I set this one as -1. Okay, so let's say for int I equals 0, I smaller than n I plus plus. Let's say if this one is even with nums I multiplied by 2 equals to 0, right? Then you can try to find the ranges which have odd number only. So let's say those kind of range is I minus 1 is from last plus 1 to I minus 1, right? So it's this range. So we'll say this count means count equals I minus 1 minus last minus 1 plus 1, right? So that is, let's get rid of this. So we just have result minus equal to 1L multiplied by count multiplied by count plus 1 divided by 2. In the end, the last, you see, the last is here, right? So there are still ranges here. So we are still have a minus last 1, right? 1, the n is 0, 1, 2, 3, is 4, right? So we should still have a minus the last plus one. I count the last part. So after we finish this for loop, we'll say in the last count equals a minus and also here, right? We should have a last equals a right? Every time. A minus last plus one, okay? So we'll have results minus equal to 1L multiplied by last count multiplied by last count plus 1 divided by 2. And we return result. Minus equal to count I minus 1. This is sorry, should be minus 1, okay? Okay, the time complexity is ON, right? It's mathematics, no extra space.